Tian Shen. I am blessed with a beautiful wife, 2 strong sons, and 1 acre of very fertile land in the Irrawaddy Delta. The land, it is our life. It is our home, our shelter, our food, our income. The land is the only way we know how to survive. I am a farmer, just like my father, my brother, my neighbor, and everyone else I know. I am a farmer, just like everyone else in Burma. Farming is hard. We live our lives bent over, knees deep in water and mud. We work through the rain, through the heat, and through the wind. And why do we work? So that we may eat, so our families may eat, and so we may buy a little bit of seed for next year. My back aches, my stomach growls, my heart yearns for more, but we work. It is all we know, it is all we have. We work so that we may survive. 5 harvests ago, a friend tells me we are saved. Myanmar is free. But this is a lie. We are not free. It is worse now than it ever used to be. When I go to the store to buy seed, they tell me it costs twice as much as last year. When I go to market to sell my rice, they give me half as much money as the year before. When I take that little bit of money and I go to buy eggs for my family, I can only buy 2 when I used to be able to buy 4. And when I try to find neighbors to help me harvest my fields, they tell me everyone is gone to better jobs in distant lands. But I cannot go. The land is all I have. The land is all I know. I need help. My family, they need help.
This story is representative of one of Myanmar's rural rice farmers. Of the 48 million people in Myanmar, 67% are in rural areas and depend on agriculture for their livelihood. Proximity Design's vision is to help the poorest rural farmers in Myanmar, and we're specifically looking at rice farming. This situation that Josh has described led us to our point of view that rural Burmese farmers, rice farmers, who are risk-averse and resource-starved, need a more efficient and high-quality, yet radically affordable rice farming technology so that they may increase income and realize a better quality of life. So, what we have done in the process of trying to address this solution is focus on how to create a labor-saving device for rural Burmese rice farmers. We're currently looking at many different stages in the rice farming cycle, which has helped us basically understand the way of life of these farmers and what they need at different times. So that's how we'll be presenting our prototypes to you, by looking at the rice farming life cycle, including seeding, harvest, threshing, and then the bill-paying inputs side of things that must come around once every cycle as well. And we'll start with seeding.
Hey, so I'm going to talk to you guys today about drum seeding. Drum seeding is basically where you have drums on an axle with some slits in it. And whenever you roll this thing down the field, the slits come near the bottom and rice falls at the bottom. So basically the cool thing about drum seeding is that you have evenly spaced seeds, which increases seed yield. It is really important for poor farmers where seed price is really important. The first thing I'm going to try with prototypes is figure out exactly how to optimize this yield process. And the way we did that was by taking a small handheld prototype and finding a report that basically goes the best horizontal and vertical spacing for these seeds. By varying the number of drums in the seeder, which can be modulated as you're moving this wheel and adding more yogurt containers onto it, we could, and also by looking at changing the number of holes in each yogurt container, we can change the horizontal and vertical spacing of the seeds that are deposited, which is really great for us to kind of optimize the best seeder given a length of an ounce. The next step for us was basically to figure out what is it to lug this thing around a big muddy field? What does that feel like? And how can we optimize that process? And that's when we made our ugly duckling back there, that terrible looking thing. And that was, it looks terrible, but it was a really great product for us because we could work with many people, we had them pull it, and we could watch how shorter people pulled it, how taller people pulled it. We noticed that taller people pulled it way differently than shorter people. If your shoulders go up to that bar on top, then basically you can basically use small muscles like your shoulders and your chest to pull that seeder. But if you're taller than that and it goes in your chest or your waist, then you can use much stronger muscles that will allow you to last longer. So it's much more taxing to people that are shorter. And we also realized, just by making that thing, that you can't push the seeder. When you push a seeder, you're immediately walking on seeds that you just seeded, which is not a good thing. So those two realizations led us to what Josh is demoing right now, our backpack harnessed rice seeder. Now, if Josh squats a bit, you can notice that he's going to use the exact same motion as he was taller, which means that a husband and rice team can basically use the exact same exact same seeder, without having to worry about the length of the axle and exactly how it's going to affect their muscles. And it will be just as taxing for a child as it will be for a husband, as it will be for a wife, which is really important for family harness. Yeah, I think, and so yeah, basically those two insights are going to be what's going to help us build our next year.
So within the rice farming world, there are actually two major approaches to planting. One is broadcasting, which is kind of where drum seeders fall, and the other is called transplanting. Transplanting is more labor intensive, and it's also more common in developing economies. So transplanting, basically they plant the seed in a field, and then when it's grown to a small plant, they'll transplant it to another field, and part of the goal behind this is they give good spacing to the plant so they have more room to grow and absorb sunlight and water. And it also gives them a better chance to survive against weeds. So with that in mind, we came up with what we're calling a seed net. And the idea is transplanting is very labor intensive, but there are benefits. And there is a study called System of the Rice Intensification, or SRI for short, that basically optimizes the planting and transplanting process. So our idea would be to develop a net with seed pods optimally spaced according to the SRI studies that would contain the seed, fertilizer, and a little bit of soil that will help the seed to start growing and protect it against the outside elements like pests, like rodents that could pick up the seed and eat it, which is a problem with broadcasting, and also protect it a little bit from weeds. So this could be spread out across a field and give the plants a chance to grow a little better. Another method, and this one's actually common in California, would be aerial seeding. So this is a little bit more expensive, a little bit more advanced, but potentially could be used either by proximity as a service or sold to community-based organizations that have sort of been formed by proximity throughout Myanmar. And a UAV could be built that disperses the seed as it flies over the field. And the benefit here is that it's obviously very labor saving. You could operate with one person, and you can also control a little bit more of the input. So say proximity decides to run this, they could hand this over to Farm Advisory Services, or FAS as they call it for short. And FAS could control the quality of seed being planted in the fields. They could also make sure that fertilizer and pest control is put down, which is something that farmers are often hesitant to do. And they could try and build in costs so that all of these things could be provided at around the same price that a farmer might pay to hire the labor and buy the seed themselves.
Awesome. So our partners at Proximity actually made a field visit recently, and they talked to farmers and identified another pain point in the or labor-intensive part of the cycle. So one of those was harvesting. Can you flip the slide? I was inspired by looking at agricultural equipment from the mid 1900s, and the photo. Yeah, so this is a combine harvester thresher from the mid 1900s, and so I thought, why not make a single individual powered one that someone can either push. This is just made on a wheelbarrow.
Yeah, sure. So the final stage after the rice stalks have been harvested is called threshing. The idea behind threshing is that you have to separate the rice seed from the stalk. And the most basic way that's employed is basically called flailing, and you just beat the rice stalks until the grains come off. In order to save on labor, we prototyped a little thresher that would do this automatically. So engines are becoming more prevalent, engines and motors are becoming more prevalent in Burma as the borders opened up with China and Thailand and products are starting to come in. So farmers are actually starting to purchase these motors and use them for other things. So we could build a thresher that, when hooked up with a motor, would allow farmers to basically just take those stalks and automatically have the rice grains stripped from the stalks. So this would save a significant amount of time.
And the last thing we worked with Proximity is thinking about the economic aspect of this and having some economic empathy. And we're able to produce kind of a basic model that would go through and look at this product relative to the rest of the business line. So Three things here. One would be it's all revenue based, so everything happens off of sales. So they could look at previous products, extrapolate from that, comparably what they thought some of these products might do versus products that are in the market, have that as their sales number, and then everything here, cost of goods sold, design costs, everything generated off of sales. They can also think about variable inputs, so everything in blue here, they can vary based on their situation, based on the analytics they have already, and figure out, okay, what's the market size, what are operating costs, what will be the net margin. And then lastly, there's actually some stuff in here for financing. So everything, it seems like that Proximity offers and for developing world farmers is financed in some way. So you could fool around with your down payment for your repayment rates and also your default rate, and factor that into your revenue as well as other parts of the model. And then lastly, if this will be a money-losing product, but essentially something within the company that they think makes sense, how would you subsidize that through other cash flows of the company, and how would that affect your overall operating margins?
So as you can see, our solution space is still fairly wide. We're excited because this has forced us even to better understand the full cycle of rice farming, which I think will lead to a better product that's more relevant. We've also looked at modular designs where we could put add-ons to a seeder to make it useful at harvesting time. We're excited because we think these prototypes will generate wide, very informative conversations when we go in country, and we look forward to using these to generate meaningful conversation with our partner as well as the potential end users. Thanks.
Very good.